Okay, so today I'm just going to take us through patterns, sequences, and series. If I'm going too fast, please just let me know, or you can just ask your questions in the chat or raise your hand, and I will give you some time. So the first sequences, we're going to do 3 sequences, 2 series, and then we're going to do segment notations. So the first sequences we're going to do are our arithmetic sequences. Lizzie, I'm going to be talking to you since you're the only one here. Is that okay? Please switch on your mic just so I know that you're there and say hi.
Hi.
Oh, okay, great. So do you know what arithmetic sequences are?
Actually, yeah, I do, but like I totally forgot about them because like the last time I did them was in term 1 and they were giving me a problem. Yeah.
Oh, so it's been a while. So arithmetic sequences is when you have a common first difference, right? So let's say we have a sequence that looks like this: 5, 9, 13, and 17. So your arithmetic sequence is when you take your T2, which is the second term here, and minus T1, and you get the same answer as when you take T3 minus T2, for example. So here it's going to be 4 because it's going to be 9 minus 5, which is 4. And then on the other side, it's going to be the same thing because I'm going to have 13 minus 9, which is 4. Are you with me?
Yes.
Yes. So that is an arithmetic sequence when you have a first common difference, right? So I'm just going to Okay, so we're going to go through activity 1, and then you let me know when to stop or when to explain something further. Is that okay?
Yes, ma'am.
Okay. So let's do question 1.
Sorry, Pony. Kejo, could you please mute your mic? Masike? Hi, Masike. Okay, I don't think she can hear. Okay.
Okay, but I think I can mute them on my side.
Okay, can you please try to do that because it's
Okay. Okay, great. So we're going to go through activity 1, question 1. It says, given the sequence 6, 13, 20, determine the formula for the nth term of the sequence. So whenever they're looking for the nth term of the sequence, they're basically looking for the general formula. And the general formula for an arithmetic sequence is this. It's Tn equals to A plus n minus 1d. Now your Tn is your general formula. Your A is your first term. Your N is your term number, the one that you're looking for. And your D is your common difference. So basically when they wanted the general formula or the nth term, you only have to substitute your A and your D. And then you try to figure out what's the rest. So what I mean by that is when we go to this question here, when it says determine the formula for the nth term of the sequence, we're going to say, so they gave us the 6, the 13, the 20. The first thing we want to figure out is what's my A and what's my D. So remember I said that my A is my first term. So my A is going to be 6. And then my D is my difference. It's my first difference. So it's when I take 13 minus 6, or if I take 20 minus 13, which here is going to be 7 and 7. So I know that D is going to be 7. And then when I substitute it in, I'm going to say Tn is equal to, remember my formula is A plus N minus 1D. So I just substitute my A, which is 6, and I'm going to have plus N minus 1. Then I substitute my D, which is 7. And then after doing this, I just simplify this by multiplying my 7n. So I'm going to have 6 plus 7n minus 7, which is then equal to 7n minus 1. Are you with me?
Yes, ma'am.
Yes. So this is going to be our formula for the nth term of this sequence, right? Do you have any questions so far?
No.
Are you still with me?
Yes, ma'am.
Okay, so let's do B. So B says calculate the 21st term of the sequence. So now remember we said that Tn after working out A is equal to 7n minus 1, right? So when they say calculate the 21st term of the sequence, I'm looking for T21. So whenever I see an N, I'm going to substitute it with 21. So I'm going to say T21 is equal to 7 multiplied by 21 minus 1. And then I just punch that in my calculator, and I'm going to get 146, right?
Yes, ma'am.
Yes. And now C says determine which term of the sequence is going to give me 97. So now I'm no longer looking for this Tn here. I'm looking for this N. Do you see that?
Yes, ma'am.
So you must just be careful to know what they're looking for. If they say calculate the 21st term or what is going to be the 19th term, then you know that I'm looking for Tn. But the minute they ask you to determine the term of the sequence and they give you the sequence, then you know that you're looking for the N.
Okay, ma'am.
Yes. So now we're going to say that 97 is equal to 7n minus 1. And then you solve for n like you would in any algebraic equation. So you're going to bring the 1 this side, and you're going to say 98 is equal to 7n. And then you just divide by 7 on both sides. So I'm going to say 98 divided by 7, and that's going to give me 14. Did you see it?
Yes, ma'am.
Okay, great. Okay, now let's go to question 2. Now in question 2, it says consider the number pattern 852, and then it says calculate the 15th term, right? But before we can calculate the 15th term, I know that I have to first figure out what my general equation is. So what did I say is the first thing you have to figure out when you want your general formula?
You first have to identify your A, and then you find their common difference.
Yes, which is your D. That's perfect, right? So in this number 2, what do you think your A is going to be?
Our A is 8.
Our A is equal to 8, and our D
Is -3.
is -3. Perfect. So you substitute that in. So you're going to say Tn is equal to 8 plus n minus 1 multiplied by -3, right?
Yes, ma'am.
And then you multiply your -3 in. So it's going to be Tn is equal to 8 minus 3n plus 3. And then you're going to say Tn is equal to 11 minus 3n. So now, since we have this, we can calculate what our 15th term is going to be. Please do that for me and give me the answer.
Okay, ma'am.
Masike,
Our
okay, sorry about that, Lizzie. Masike, if your background noise has reduced, can you please raise your hand so that Moiponi can unmute you?
Oh, sorry. Okay, Masike, if you can't unmute, please just type any questions you have on the chat. Okay, I think then we can carry on. Lizzie, did you find T15?
yes, ma'am.
What's the answer?
What? The 15th term. Ma'am, I didn't see A. I found B. Let me do A.
Okay, what's your answer for B?
My answer for B. My answer for B is 100.
100, okay.
Yes,
You'll let
ma'am.
me know how you got that now, okay.
Yes.
Okay, calculate the 15th term for me, please.
Yes, ma'am. Plus 3, 15, 11, 34. Okay. My answer for letter A is -34.
-34, that is perfect. So you just substituted the 15 here, right?
Yes, ma'am.
And then you got -34, okay. So please explain to me how you got B.
On B, I took my general formula, which had
Okay.
Tn is equal to -3n plus 11. And then where there is Tn, I substituted -289, and then I did my math.
Okay, no, that's perfect. Okay. So for everyone who just joined, we are on question 3. You guys can unmute your mics if you don't mind. Okay, so in question 3, they tell you that this is another arithmetic sequence, right? So you already know that T2 minus T1 is equal to T3 minus T2. So it says, given the arithmetic sequence 1 minus p, 2p minus 3p plus 5, determine the value of p. And these type of questions, especially number 3, is the type of questions they like to ask in exams, prelims, and your final exams. So they normally never ask these. They normally give you something like number 3, and then they ask you to work out the variable or stuff like that. So now 3a says, given that this is an arithmetic sequence, determine the value of p. So since we know that t2 minus t1 is equal to t3 minus t2, we're going to take, so this is t1, and that's t2, and that's t3. We're going to substitute t2 into this equation that we made for ourselves, So we're going to say 2p minus 3 minus, and don't forget to put the first one in the bracket, 1 minus p is equal to, then you go to your t3, p plus 5 minus my t2, which is 2p, sorry, I ran out of space there, minus 3. And then you just close the bracket. And then you just solve for p like you would in any other equation. So you're going to say t2p minus 3 minus 1 plus p equals p plus 5 minus 2p plus 3. And then you take all your like terms to one side. So you're going to bring all your p's to the left. So I'm going to have 2p plus p minus p plus 2p equals, and then I take all my coefficients on this side, and then I'm going to have 5 plus 3 plus 3 plus 1. And then I just solve for p. So I'm going to have 2p plus p, that's 3p, minus p, that's 2p, plus 2p, I'm going to have 4p on this side. And then on the other side, I'm going to have 5 plus 3, which is 8. Plus 3 is 11. And then 11 plus 1 is 12. So then my p is equal to 3. Are you guys with me?
Or it's from A to D again?
Excuse me?
Yes.
Hello?
So now, what is the
Everybody,
distance? I
and
know
if
it's from
we
A
can
to D.
mute him.
Yes. What is the distance from A to E? From A to E.
What?
Mute Bunny.
Okay, are you guys with me?
Yes, ma'am.
Oh, okay, great. So did you understand how I got the p?
Yes, ma'am.
Okay, great. So now B says determine the value of the first 3 terms of the sequence, right? So I know that my P is equal to 3. So the only thing I have to do here is say that T1 is equal to, so I just substitute the P back into these formulas that I have here. So I'm going to say T1 is equal to 1 minus, and then whenever I see P, I just substitute the 3. And then T2 is equal to 2P minus 3. And then T3 is equal to P plus 5. So my T1 is going to be negative 2. My T2 is going to be 2 multiplied by 3, which is 6, minus 3, which is 3. And then I'm going to have 3 plus 5, which is 8. Does it make sense?
Yes, ma'am.
Okay, does anyone have any questions so far? Okay, I'm guessing that everyone is still okay. So this is an arithmetic sequence. Remember that your first difference is the same. You have a common first difference. These are the ones that are pretty easy. So these, you shouldn't lose any marks here. Just focus, use your calculator and make sure that you punch everything in correctly. Okay, so now we're going to move to a quadratic sequence. Now your quadratic sequence is when you don't have a first common difference, but you have a second common difference. So it's when you have something that looks like this. When you have a 6, a 12, 22, 36, and 54. Sorry. And 54. And you try find the first common difference, right? When you do that, you'll see that it's not common because when you say T2 minus T1, you're going to get a 6. And when you say 22 minus 12, you're going to get a 10. And when you say 36 minus 22, you're going to get a 14. 54 minus 36, you're going to get an 18. But what you do realize is that you do have a common second difference because when I take my 10 minus 6, I get a 4. So I'm just going to write it here. So when I take my 10 and I subtract it with the 6, I get a 4. And when I take my 14 and I subtract it with the 10, I also get a 4. So this minus this gives me 4. That minus that gives me 4. And 18 minus 14 gives me a 4. So I don't have a common first difference, but I have a common second difference, which is going to be 4. Are you with me?
Yes, ma'am.
Okay, so the trick here is to always figure out okay, before we go there, right? Let me just go to a new paper because I want to show you something. Whenever you see a quadratic sequence, right? You must always remember this formula. So with each and every quadratic sequence, you must just remember this formula. I have an A plus B plus C. And then you write a 3 in front of it. This is it simplified, right? And then underneath it, you're going to write 3A plus B. And then next to it, you write a 2. And then you go underneath it and you write 2A. And then next to it, you write a 1, right? So you must always, always, always remember these 3. Number 1 is 2A, 2 is 3A plus B, and 3 is A plus B plus C, right? So if the question says that you have a 6, a 10, a 14, and an 18. No, sorry. It's a 6, a 12, 22, and 36. And you find your first common difference and you see that it's not the same. Because here it's 6, it's 10, and there you're going to have 14. You go to your second difference, right? Which is 4, and that's going to be 4. So you just realized that, okay, fine, I don't have a first common difference that's the same, but I have a second common difference. And this lets me know that it's a quadratic formula. It's a quadratic sequence. Are you still with me?
Yes, ma'am.
Okay, so the minute you have these, you go to the bottom. So you go to your second common difference, right? And you label it 1. And you go to my second row and you label it 2. And you go to my third row, which is the one they gave you, and you label it 3. Still with me?
Yes, ma'am.
And then what you're trying to figure out here, because remember, for quadratic sequence, the formula is Tn is equal to an squared plus bn plus c, right? So the only thing I'm trying to figure out here is what's my a, what's my b, and what's my c. Because remember, with my arithmetic sequence, I only wanted to find out what's my a and what's my d. Do you remember that?
Yes, ma'am.
But now with my quadratic sequence, I have to find out 3 variables, which is my a, b, and c. So the minute I have these 3 rows here, which is my 4, 6, 10, 14, and 6, 12, 22, 36, I start making equations for myself. Where I see a 1, I equate them. So what I'm going to do is I'm going to say 1, I write a 1 underneath them, right? And then I go to my row on the left-hand side, which is my 2a. Do you see it?
Yes, ma'am.
I go to my 2. Okay. So I'm going to say 2a is equal to 4. Do you see where I got the 2a and where I got the 4?
Yes, ma'am.
Yes, ma'am.
Yes. And then I go to 2. And then I'm going to say 3a plus b is equal to 6. Do you see where I am?
Yes, ma'am.
And then I'm going to say number 3. A plus B plus C is equal to 6. So on my right-hand side, the only things I'm concerned with are the first numbers. So I'm concerned with the 6, with this 6, and with this 4. Are you with me?
Yes, ma'am.
And then once I've figured all of this out, once I have these 3 equations, then it's going to be easy for me to calculate what's my A, what's my B, and what's my C, because that's ultimately what I'm looking for, remember. So now I'm going to start calculating. I'm going to say 2A is equal to 4. Therefore, what's my A?
It's 2.
My A is equal to 2. And then I go to my second one. This is 1. My second one is 3A. So now I can substitute the A into this 3A. Do you see it? So I'm not going to write 3A anymore. I'm going to say 3 multiplied by 2, close bracket, plus B is equal to 6. And then I solve my B. So what's B going to be?
1.
B is going to be 1. Wait, say that again. What's B going to be?
B is going to be 1.
Just hold on.
No.
What's B going to be?
B is going to be 0.
0. Thank you.
Yes, ma'am.
Okay. And then my 3, what's 3 going to be? Okay, I'm just going to write 3 here because I'm running out of space. So I have my A, which is 2. My A is going to be 2. My B is going to be plus 0 plus C. So what's my 6? My C going to be?
4.
C is going to be 4. Perfect. And then what do? I just say Tn. Say therefore, Tn is equal to, what was my A?
2.
2n squared plus my B was 0, so I don't have to write it because
Yes,
0 multiplied by n is going to be 0. And my C, which was 4,
4.
right? So my Tn
Yes, ma'am.
is therefore 2n squared plus 4. You with me?
Yes, ma'am.
Okay, great. Now let's come here. Let's do activity 2. So activity 2 says determine the general term for this pattern, right? So whenever you get a question like this, you first have to find out if it's an arithmetic sequence or a quadratic sequence. And how do you do that? You first find your first term, right? So I'm going to say 3 and 13, 31, 57, and 91. So I find my first difference. And my first difference here is going to be 10. Second one is going to be 31 minus 13, 18. And then I'm going to have 57 minus 31, which is 26. And 91 minus 57, which is 34. Are you with me?
Yes, ma'am.
So automatically, this tells me that this is not an arithmetic sequence. So now I find the second difference to see if it's a quadratic sequence, right? So I'm going to say 18 minus 10, that gives me 8. 26 minus 18, that also gives me 8. 34 minus 26 also gives me 8. So this tells me that it's a quadratic sequence, right? And I said that whenever you see quadratic sequence, you already in your mind have this equation of A plus B plus C. That's 3, 2. What did I say 2 was? I said
3A plus B.
3A plus B. And what's 1?
1 is 2A.
1 is 2A. So I already know this. This you must commit to memory. So you walk in the test knowing this already, right?
Yes.
And then I said you look at your first numbers here. So I'm going to focus on the 8, the 10, and the 3. Still with me?
Yes, ma'am.
And then I equate them, right? So I'm going to say that my 2A, that's number 1. Remember, this is 1, that's 2, and that's 3. So I'm going to say that my 2A is equal to 8, right?
Yes, ma'am.
And then my second one is going to be 3A plus B. What's this equal to?
Is equal to 10.
Equal to 10. And then my third one, which is A plus B plus C, what's that equal to?
Is equal to 3.
3. Perfect. And then I just come to the first one and I calculate what my value for A is. Yeah. So what's my value for A going to be?
4.
It's going to be 4. And then I substitute the 4 in here. What's my value for B going to be?
Negative 2.
Negative 2. And my value for C?
1.
Yes, n is equal to 4n squared minus 2n plus 1. Are there any questions so far? Okay, so I'm guessing everyone is still okay. Everyone is still with me. All right, so let's move over to B. So B says calculate the 7th term of this pattern. So now I already have my Tn, which is my general formula, which is Tn is equal to 4n squared minus 2n plus 1, right? So if they want the seventh term, I'm going to say T7, and whenever I see a n, I just substitute it with a 7. So I'm going to say 4 multiplied by 7 squared minus 2 multiplied by 7 plus 1. And then I just punch that in my calculator. What's the answer?
183.
183. That's perfect. Okay. And then question C says, which term is equal to 241? So I always go back to my general term, which is my Tn. So I'm going to say Tn is equal to 4n squared minus 2n plus 1. So here, I'm no longer looking for Tn. I'm looking for my n value, right? Because it says which term is equal to 241. So they give you your Tn, which is 241. Plus 1. So I just solve it like I would any quadratic equation. I'm going to take my 241 on the other side and make it equal to 0, right? So I'm going to say 4n squared minus 2n plus 1 minus 241. Okay, Lizzie, please solve this one for me and give me the answer. If you can't, it's fine. You'll just let me know.
Okay, ma'am, let me try. Let me solve it.
Okay.
I got my n as 8 and also as negative 15 over 2, and
Okay.
obviously we know that n cannot be a fraction, so n is not equal to negative 15 over 2.
Okay, that's perfect. So what did you do here? You simplified this first, right?
Yes, ma'am.
And then you got 2n squared minus n minus 120. If you simplify this, right? And then that's when you take it to your 2 brackets, which is going to be 2n plus 15 and n minus 8. And that's how you got n to be 8, right?
Yes, but I did not use it. I did not use that strategy. Instead, I used the quadratic formula.
Oh, okay, yes, that also makes things easier for you. Okay,
Yes,
that's
ma'am.
also perfect, yes. So you got n to be 8, that's perfect. Okay, now let's move over to question 2. Question 2 says, find term 6 of this pattern and then find the rule in the form of Tn is equal to an squared plus bn plus c. So whenever you see them say find the rule, you know that it's just the general term. Okay, don't let that confuse you. It's the exact same thing. So what they're basically saying is that find term 6, or they want to know what T6 is. So you first have to find that general term. And the general term, we're going to find it like we've been finding it before, right? So I have a negative 1 a 3, a 9, a 17, and a 27. Siki, I'm not sure if you want to ask a question.
I'm so much.
Oh, okay. Are you with me though?
Yes, I am.
Okay, great. Don't forget, you can also type in the chat or you can just ask whenever you need to.
Thank you.
All right. So now we find the first difference. My first difference here is going to be 4. Then I have a 5 there. No, sorry. To be 4, 6, 8, and 10. And then my second difference here is going to be 2, 2, and 2. And the fact that this is common tells me that it's a quadratic sequence, right? And whenever you see a quadratic sequence on the side, you already know that 3 is going to be A plus B plus C. 2 is going to be 3A plus B. And 1 is going to be 2A. So now where do you guys think I'm going to go from here?
You take every first term of those patterns. Then on number 1, which is 2A, you equate it to 2. Then number 2, you equate it to 4. And then number 3, you equate it to -1.
Yes, that's perfect. Okay, can you guys please work out A, B, and C for me?
A is going
Okay.
to be 1.
And your C,
And
3. Perfect. So when I write it, I'm going to is equal to n squared plus n minus 3, right?
yes, ma'am.
Yes. And then what's my T6 going to be?
Your T6.
Because remember, yes, they said find the term 6 of this pattern.
Okay, ma'am, let me find 8. Can I answer, ma'am?
Yes, you can answer.
I found my term 6 as 39.
39. Yes, that's perfect. Your term 6 is going to be 39. So what do? You just substitute a 6 whenever you see n, right?
Yes, ma'am.
So I'm going to say T6 is equal to 6 plus 6 minus 3. No, sorry, is this right? I'm missing something.
You forgot this squared.
Yes, that's what I did. So what's I'm going to say 6, and then I just punch it into my calculator, right?
Yes, ma'am.
And then you're going to get your 39. I hope everyone is still with me before we move on. Are there any questions? Okay, I'm going to take that as a no. Okay, now we're going to move to geometric sequences. So remember, we started with arithmetic. Arithmetic is when I have a common first difference, right? And then I moved over to quadratic. Quadratic is when I have a common second difference. And then this one is when I have a common ratio. Now, what we mean about common ratio is, for example, if I have a sequence that looks like this, 5, 15, 45, 135, and 405. This is my T1, T2, T3, T4, and T5. So what I mean by common ratio is that if I take my T2 and I divided my T1, then that should equal to T3 over T2, which is equal to T4 over T3, and so on and so on. Do you understand? So it's when I divide them. So it's like with this one, if I say 15 over 5, this gives me a 3, right? Are you guys with me?
Yes, ma'am.
Yes, and okay. And if I say 45 over 15, what does that give me?
3.
It also gives me a 3. So do you see what I mean by common ratio?
Yes, ma'am.
Okay, great. So with all these formulas, you're going to get them on your formula sheet. So just know which one applies to which. So this Tn equals to A R n minus 1 is going to be on your formula sheet. So you know that your Tn is your general formula, right? And your A still is your first term. Your R, so this is your general formula. Your A is your first term. Your R is going to be your common ratio. So in the example I just did, it will be your 3, right? And then your N is your term number. Are you with me?
Yes, ma'am.
Okay, cool. Now let's do a few questions on this. So activity 3 says determine the 10th term of the sequence 3, 6, 12, right? So you write your 3, your 6, and your 12, and you check. Does it have a common ratio? You're going to say 6 over 3. This gives me 2. And then you say 12 over 6, which gives me 2. So I know that this is a geometric sequence because it has a common ratio, right? So automatically I know that my R is equal to 2. And then what's my A in this sequence?
3.
Yes, it's going to be 3. So then you go to your general formula, which is Tn is equal to AR n minus 1, and you substitute your A and your R. So you're going to say Tn is equal to 3 multiplied by 2n minus 1. Understand? So now with this question, it says determine the 10th term of the sequence. So I'm just going to say T10, and wherever I see a n, I substitute with a 10. So I'm going to say T10 is equal to 3 multiplied by 2, 10 minus 1. And then I just punch that in my calculator. What do I get?
1,536.
Please say that again.
1,536.
Yes, that's perfect. Does everyone know what?
Yes, ma'am.
Okay, great. Now let's move over to question B. It says determine the number of terms in the sequence 2, 4, and then my last term is 1, 0, 2, 4, right? So what are they looking for here? Are they looking for my Tn or are they looking for my n?
They're looking for n.
They're looking for n, right?
Yes, ma'am.
So we're gonna first start by figuring out what's my general formula, right? So I'm going to start with Tn is equal to ARn minus 1, right? And I'm going to say Tn is equal to, what's my A?
It's 2.
2. And then how am I going to calculate my R?
You divide the second term with the first term.
Yeah, so what is it going to be?
2.
2. And then I'm going to have a n minus 1, right? So now they want me to figure out what n is. So here by Tn, I'm going to substitute this number. 1,000. To start by dividing by 2. So when we take my 1024 divided by 2, I get 512 is equal to 2 to the power of n minus 1. Is everyone still with me?
Ma'am, may I ask,
Yes, you can ask.
why did you not say 2 times 2,
Remember,
but instead you,
okay, carry on.
I was asking why you did not multiply 2 with 2, but instead you left the other 2 outside the bracket.
Oh, okay, I get your question. So when you guys are going to do it sometime this week, when you do your exponential equations, right? If you have x, no, sorry, let me erase that. For example, if you have 5 to the power of x is equal to 25, and I want to know what x is, right?
Yes, ma'am.
I think this is going to ring a bell in a minute. Yeah. So I know that 25 is equal to 5 squared, right? I can write it like that. Are you with me? Okay, no,
Yes,
let me
ma'am.
explain it like this. Sorry, I'm going to confuse you. Let's do this. So if I have 2 squared plus 4 squared. Oh, no. 2 squared multiplied by 4 squared. Is it okay if I multiply these bottom terms? Do you think that's how I'm going to solve it?
No.
Okay, Same way, if I have an a squared multiplied by my a cubed, is it right that I can just add my exponents?
Yeah.
I can say this is equal to a to the power of 5, right?
Yes, ma'am.
Yes. But now here, it's not the same because my exponents are not the same. I'm not explaining this right. Please just give me a minute to think this through. I'm gonna be with you now. So this 2 here, that's on the outside, right? It's the same as me having 2a to the power of 2. Do you understand it? So this 2 that's on the outside here is not connected to this 2 that's on the inside. That's why it's in a bracket, because it has its own exponent.
Oh, yeah,
So the
I
minute,
understand now.
yeah, so the minute I want to solve this, let's say I said this is equal to 8, right? What am I going to do first? I'm first going to start by dividing by 2 on each side, right?
Yes,
To
ma'am.
get rid of this 2. And then only do I focus on the a. Are you with me?
Yes, ma'am.
Because it has an exponent on its own. So the same thing applies here. I get why you want to multiply this 2 with this 2, but this 2, remember, is not standing alone. It has an exponent, which is n minus 1, which
Yes,
is
ma'am.
this here. So the fact that I have this means that I can't multiply this 2 here. So the same thing I would do with this 2 in front of this a is what I'm going to do with this 2. I'm going to get rid of it.
Yes,
Are you
ma'am. I
with me?
understand now.
Yes. So that's why here I divide by 2 first. And then I have 512 equals to 2n minus 1. Are you with me?
Yes,
So
ma'am.
just remember not to make that mistake. These 2, I know it's very tempting for you to just multiply it in, but this 2 that's inside the bracket has an exponent on its own. So that means I can't do anything about it. I can only get rid of this 2 that's in front of it. Are you with me?
Yes, ma'am.
Okay, cool. So what do you think we're going to do here? How do you solve exponential equations when it comes to this? I make my bases the same, right? So now I have to figure out which base here will give me 512. So 2 to the power of what will give me 512, so that I can have a 2 on both sides and I can drop them so I can have an n minus 1.
2 to the power of 9.
2 to the power of 9, right? And then what do? I just drop my bases and I have 9 is equal to n minus 1. So what's my n?
10.
N is equal to 10. Does it make sense?
Yes, ma'am.
Okay, great. Okay, so does that mean we can move over to C? Okay, C says if 5x and 45 are 3 terms of a geometric sequence, determine the value of x. So we know that with a geometric sequence, T2 over T1 is equal to T3 over T2, right? So I'm just going to substitute my values into this for me to work out x. So I'm going to say T2, which is x, over my T1, which is 5, is equal to T3, which is 45 over x. And then I just solve for x. So how do you think I'm going to solve for x here?
You cross multiply.
Yes, I'm going to cross multiply. So I'm going to have an x squared And then 45 multiplied by 5. That gives me 225. That means that my x is equal to plus minus 15. Are you with me?
Yes, ma'am. Ma'am,
Okay, great. Yes.
could you please clarify the matter of plus or minus? Like, when exactly do we say
Oh.
plus or minus, or just leave it as positive?
Plus minus is whenever you take the root of something. Because remember that whenever I take the root, you know, when we did that previous one and you had two brackets and you said that n is equal to something, and then you said or n is equal to, remember this?
Yes, ma'am.
Yes. So whenever you take the root of something, you always know that I'm going to have two answers for n, a positive and a negative one.
Oh,
Yes. So that's why we
okay.
say plus minus. But then when you write your final answer, just remember to say that therefore x is equal to positive 15, because you can see that in the sequence, my number is going to be a positive.
Yes, ma'am.
Do you see that?
Yes, ma'am.
So just remember
understand
that.
now.
Yes. So whenever we take the square root of something, just remember that it's always a positive or a negative answer. Actual answer. And then you have to decide if it's a positive or if it's a negative.
Okay, ma'am. Thank you.
Yes. Okay, you're welcome. Okay, let's go for D. D says determine the geometric sequence whose 8th term is 9 and whose 9th, oh, sorry, I didn't read that properly. It says determine the geometric sequence whose 8th term is 9 and whose 10th term is 25. So basically they're telling you that T8, sorry, is equal to 9 and T10 is equal to 25. And they want you to find what Tn is. Rn minus 1, right? Are you with me?
Yes, ma'am.
Yes. So if you have a question like this, then what you know is that AR to the power of 7, because remember that this is your general formula for any geometric sequence, right? So if they tell me that T8 is equal to 9, then I'm going to say AR to the power of 8 minus 1 is equal to 9, right? And then here, if I simplify it, it's going to be AR to the power of 7 is equal to 9. And then I also know that this one here is going to be AR to the power of 10 minus 1, which is equal to 25. So that means that AR to the power of 9 is equal to 25. So then all you do is that you make an equation for yourself. So this side, so you're going to say AR to the power of 9 over AR to the power of 7 is equal to 25 over 9. I'm not sure if you're still with me. Lizzie, are you with me?
Yes, ma'am.
Okay, did you see what I did there?
Yes, I did, but I'm waiting for you to finish so you can repeat it again, because I'm kind of lost somehow, but I do saw what you did, but
Okay.
I don't understand.
Okay, let's start over, right? So they said that T8, which is my 8th term, is equal to 9. Right? Now
Yes, ma'am.
remember that if I have T8, this is my general formula. Tn is equal to A R n minus 1, right? So this 8 is my n, basically, right? So I'm going
Yes,
to
ma'am.
substitute the T8 with this. So I'm going to say A, because I don't know what my value for A is. R, I don't know what my value for R is, but I do know what 8 is, what n is, and get it's 8. So I'm going to say 8 minus 1, and then I'm going to equate all of that to 9. Still with me?
Yes, ma'am.
Yes, so I'm going to simplify this and say AR to the power of 7 is equal to 9. And then I'm going to move over to this 10. They say that my 10th term is equal to 25. So I'm going to say T10 is equal to 25. And then I come back here to my Tn is equal to AR to the power of n minus 1. So I'm going to say A, which I don't know the value of, R, I don't know the value of it. I do know that my n is 10 minus 1, and that is equal to 25. And then I'm going to say AR to the power of 9 is equal to 25. Are you with me?
Yes, ma'am.
And then I'm going to take these two formulas that I did there, and I'm just going to find, remember when I told you that whenever I'm looking for R, I take my T2 over my T1.
Yes,
So I'm
ma'am.
basically going to do this with both equations. So I'm going to take this last one and this last one and equate them. So I'm going to say that my AR to the power of 9 over my AR to the power of 7 is equal to this 25 over 9. And then we're using this equation, I'm going to try to solve the value of R, because I don't know if you can see it, but these A's already are canceling. Do you see that?
Yes, ma'am.
So what I have basically on my left-hand side of that equation is R to the power of 9 over R to the power of 7 is equal to, and then 25 over 9 on this side. Therefore, here, I'm going to be left with R to the power of 2 is equal to 25 over 9. And then I square root that, then my R is equal to 5 over 3. Are you with me?
Yes, ma'am.
Okay, great. So now that I have my 5 over 3, which is my R, I can now calculate N. I can now calculate A, right? You see that?
Yes, ma'am.
So I have my R, which is equal to 5 over 3. So I'm going to say that my A, wait, let me write it like this. So remember that my T, you can either use your T10 or your T8. So let's just use T8. I'm going to say that my T8 is equal to 9. And my T8 was A. I know what my R is. It's 5 over 3. And because it's 8 here, I know it's going to be 8 minus 1 is equal to 9. Therefore, my A, 5 over 3 to the power of 7 is equal to 9. And then you just divide by 5 to the power of 7 to get your A. Okay. 5 over 3 to the power of 7. And that should give you your A. So I'm just going to write it as this. 9 multiplied by 3 over 5 to the power of 7. Are you with me?
Ma'am, is it multiplied by or divided by?
Here, I'm going to multiply it. Remember when if I have 1 multiplied, no, sorry, 1 divided by 3 over 5, it's the same as saying 1 multiplied by 5 over 3.
Oh, yeah,
Yes,
I get
so
you,
that's
ma'am.
what I did here. When I brought it to the other side, I divided it, and then I just switched my terms. Do you see why now it's 3 over 5?
Yes, ma'am.
Okay, great. So are you happy with the seat we did? Remember arithmetic? We did quadratic, so did
More practice with it.
oh, I get what you're saying. Yes, I think we'll do those. Let's just finish with the series, because with series, we only have 2 series. And then we'll come back to geometric sequences, and then we'll practice it a bit more. Is that fine?
Okay, ma'am. Yes,
Okay,
ma'am.
cool. So remember with sequences, we were just listing numbers, right? So we had like we had something like this. We had like 2, 4, 6, and then we were just listing them, right? This is a
Yes, ma'am.
sequence. But now when it comes to a series, we start adding them. So it's going to be 2 plus 4 plus 6. So that's the difference between your sequence and your series. Are you still with
Okay.
me?
Yes, ma'am.
So this is the formula for an arithmetic series when we start adding them. So with series, you have an arithmetic series and you have a geometric series, and both of them have proofs of the equations. You do know that, right?
Yes, ma'am.
Yes. So with those proofs, please study them. You have to know them, commit them to memory, because I know they either ask one or the other. So just make sure that you're comfortable with them and you know them. The arithmetic arithmetic series proof and the geometric series proof.
Okay, ma'am.
Yes, please just note that down somewhere so you don't forget that I have to know them, the 2 proofs. Okay. So now let's go into arithmetic series. An arithmetic series has a common difference. Remember when we did the arithmetic sequence, it had a common difference, right? The common first difference.
Yes, ma'am.
Yes, so the arithmetic series is the exact same thing. The only difference is that we're now adding them. And we're using a different formula, which is this one. So
19.
19 plus n minus 1. What's my d?
It's 3.
3. And then I just solve for n, right?
Yes, ma'am.
Yes. Sorry, I'm just trying to figure something out quickly. Yes, and then I just solve for n. So my n here is going to be 35. Did you get the same answer?
Yes, ma'am.
Okay, great. So now once you have this 35, you can go to this equation here and then just substitute. So my equation says that Sn is equal to n over 2 a sorry, please just hold on quickly. I just want to see something. So Sn is equal to n over 2, 2a plus n minus 1d, right?
Yes, ma'am.
Yes, so I'm just going to say S35 is equal to, then I just substitute. I'm going to say 35 over 2, what's my A?
19.
19 plus n minus 1, n is going to be 35 minus 1 multiplied by my d, which is 3, right?
Yes, ma'am.
And then I just punch that in my calculator. What's my S35 going to be?
Mm. 2,450.
2,450. So you understand how we got to this?
Yes, ma'am.
Okay, great. Now, the second one says the sum of the series 22 plus 28 plus 34 is 1,870, right? And then it says determine the number of terms. So how do you think we're going to do this one?
The sum of the series 22 is determine the number of terms.
What are we looking for? Are we looking for my Sn or are we looking for my n?
We're looking for n.
We're looking for n, right? So we write the
Yes, ma'am.
equation. We start by writing the equation, which is Sn is equal to n over 2 bracket 2a plus n minus 1d, right? So my Sn
Yes, ma'am.
is 1,870, which is equal to n, that's what I'm looking for, over 2a. What's my a?
It's 22.
22 plus n, I'm looking for it. And what's my d?
Is 6.
6. Perfect. And then I just solve for n, right?
Yes, ma'am.
So I'm going to say 1,870 on that side, and then I'm going to multiply it by 2. And then this side I'm left with n. 2 times 22, 22, 44, plus 6n minus 6. And then I multiplied my n this side. equals 0. And then this, I take everything to one side. Are you still with me?
Yes, ma'am.
Oh, okay, cool. 44 minus 6, 22. Okay, and then after this, you just do your quadratic formula. Please let me know when you're done doing your quadratic formula.
I'm done.
What did you get?
N is equal to negative 22. No.
N is equal to?
Wait, ma'am, I made a mistake.
Okay.
It's positive 22.
Yes, positive 22. Perfect. Are you okay?
Yes,
So
ma'am.
you saw how we did all of that, okay? Now let's do question
Yeah.
3 quickly. It says the first and second term of an arithmetic sequence is 10 and 6, respectively. Calculate the 11th term of the sequence. So you know how to do this, right? How are we going to do this?
The first and second terms of an arithmetic sequence 10 and 16 respectively. Calculate the 11th term. Let me see. The first.
So they're basically telling you that
Oh, yeah.
T1 is equal to 10 and T2 is equal to 6. And they want T11. So we go to our general formula, which is Tn is equal to A plus N minus 1D. Right?
Yes, ma'am.
And then we're going to say T11 is equal to, what's my A?
I haven't done it.
Oh, A is going to be 10 because remember, A is always your T1. Do you see it?
Yeah.
Yes.
Yes.
So A is going to be 10 plus my N is 11 minus 1. And my D is going to be?
Negative 4.
Negative 4. And then I just solve. And I just punch this in my calculator. So what's my T11 going to be?
Let me do it. 10 minus 11. It's 16.
What did you get?
Negative 30.
Negative 30. Yes, that's perfect. Okay, great. And then your B says the sum of the first n terms of the sequence is negative 560. And then it says calculate n. right? So they say the sum of the first n terms of the sequence is equal to negative 560. So we need to calculate n. So we start with our equation, which is Sn is equal to n over 2, 2a plus n minus 1d, right?
Yes,
And then I
ma'am.
know that Sn is equal to negative 560. And then I just calculate n. So I'm going to say n over 2 is equal to 2. And I know that a is
It's 10.
a is 10, yes. Plus n, that's what I'm looking for. Minus 1. And what's my d?
Negative 4.
Negative 4. And then I just solve for n. Please solve for n for me quickly and let me know what you get.
Okay, ma'am.
Are you still okay?
Yes, ma'am.
Okay. Just let me know when you're done.
Ma'am, is it possible to get a fraction?
It is possible, but I don't think you should be getting a fraction with this one. What did you get?
Positive 19.5 and negative 14.3.
Okay, your answers are close. Let's see what happened. Your answers are close, but they shouldn't be fractions. They should be whole numbers. Okay, so where did you start?
Okay.
You started by multiplying the 2 over, right? And you got
Yes, ma'am.
negative 1,120 is equal
Yes,
to
ma'am.
n. And your first bracket, you have 20 plus, okay, 20 minus, sorry. 20 minus 4n plus 4. Something like that.
Yes.
Still with me. And then you're going to say 20n minus 4n squared plus 4n. And then I'm going to say 0 is equal to negative 4n squared plus 20n. And then if I take that side is going to be plus 1124. Were these your numbers when you did it in the quadratic?
Yeah, I made a mistake where there's 20 n. I don't know where I got the other n, but instead of 20, I said 21.
Oh, so you
Yeah.
see where your mistake is, yes. So for
Yes,
this
ma'am.
one, your n is supposed to be 20. So you're going to get two
Yes.
numbers. 20 is going to be n is equal to 20 or n is equal to negative 14. But because
Okay, ma'am.
it's a negative, we're not going to be using it. So we're just going to stick to the n is equal to 20.
Okay.
Okay, cool. Okay, let's move
Ma'am,
over to the next one. Sorry?
Why did you not take the negative 14 for n? N cannot be a negative.
N cannot be a negative because remember that your n is signifies which term it is. So it's a term number. And your term number always starts with 1, and then it moves over to 2, and then moves over to 3, and then it moves over to 4.
Oh, okay.
So it's always increasing. And that's why your n cannot be a negative. So we always say
ma'am.
T1, T2, T3. These numbers here can never be negative.
Okay.
Do you
ma'am.
get it? Okay.
Yes.
Okay, great. Okay, now we're going to move over to geometric series. So the only thing you need to remember with your geometric series, right, is that our formulas are almost the same. The only difference is that if your number, your R is your common ratio. Remember we did it when we were doing geometric sequences.
Yes, ma'am.
R is equal to, sorry, your R is equal to T2 over T1. If this answer here
Yes, ma'am.
is more than 1, then you know that we're going to use this first formula. But if this answer here is less than 1, then you know we're going to use the second one. Does it make sense?
Yes.
So just remember these two. That this one, when my 1 comes before my R was less than 1. But if my R is more than 1, then my R comes first in my formula. But I think it'll make more sense when we do examples.
Yes, ma'am.
Okay. So now it says determine 3 plus 6 plus 12 plus 24 to 10 terms, right? So now I start by saying my R is equal to T2 over T1. My T2 here is 6 over 3, which is equal to 2. So since my R here is 2, which equation do you think we're going to use here? The first one or the second one?
The first one.
The first one, right? So we're going to
Yes, ma'am.
say that Sn is equal to A. Please just hold on. Rn minus 1 over R minus 1, right? So S10 is equal to, what's my A?
3.
3. My R?
2.
2 to the power of?
10.
Minus 1 over R, which is 2 minus 1. So what's my S10 going to be?
3069.
3069. Yes. So do you see what I mean? That if your R is more than 1 and if your R is less than 1. So just remember
Yes, ma'am.
that. Okay, great. Now let's move to question 2. It says if 2 plus 6 plus 18 is equal to 728. Determine the value of n. So we start by determining what my r is first. So we're going to say r is equal to T2 over T1, which is equal to 6 over 2, which is 3, right?
Yes, ma'am.
So which equation am I going to be using, the first one or the second one?
The first one.
The first one. So I'm going to say that my Sn is equal to A Rn minus 1 over R minus 1. So it tells me that my Sn is equal to 728, right?
Yes, ma'am.
Which is equal to, what's my A?
It's 2,
2. My R is
3.
3 to the power of n minus 1 over 3 minus 1. And then we solve for n, right?
Yes, ma'am.
So I'm going to say 3 minus 1 is 2. And then 728 multiplied by 2. That's going to give me 1456 is equal to 2 over minus 1. And then I divide by 2 on both sides. And then I take my n this side. And then what to the power of 3 gives me 729.
I'm doing a
Okay.
700. Okay. It's 3 to the power of 6.
3 to the power of 6. That means that my n is?
N is 6.
N is equal to 6. Perfect. So you're still with me?
Yes, ma'am.
Okay, so we have 2 last activities to go and then we're done. We're almost done. Okay, now we're going to do sigma notations. Right? So
Yes,
sigma
ma'am.
notations, you've seen this. This is how they write it, right? So what I want you to remember for now is that at the bottom, this k is equal to 1. That's your from. So this is where you start. This is where your sequence starts. So this is your starting point. Your k is equal to 1. And then your n at the top, this is your 2. This is where you stop. So this is where your sequence ends, right? So you must remember that
Yes,
this
ma'am.
one at the bottom, where it says k is equal to 1, this is my starting point. And this one at the top, that's where I end. And then the sigma means the sum of. So for example, if I have something like this, a sigma notation of 17, and I say k is equal to 3, and then I have p to the power of k. What this basically means is I'm going to start my T1 is going to be equal to p to the power of 3.
3.
And then my last my t, my last t, my last term is equal to p to the power of 17. So this term is going to carry on, this sequence is going to carry on to p to the power of 17. Do you see what I mean by my start and my end point?
Yes, ma'am.
So I substitute the 3 in there, and I also substitute the 17 in there. So this is my last term, and this is my first term. With me?
Yes, ma'am.
Okay, so let's do examples. Okay. So this one says evaluate a 70 k is equal to 1. Okay, sorry, I copied this question wrong. It's supposed to be E 70 on top, k is equal to 1. No, sorry, n is equal to 4 at the bottom. And then you're going to have a bracket here that says 2n minus 4.
Okay, ma'am.
Okay, so what they're basically looking for here is what is the sum of this sequence? So what is the Sn of this sequence, right? So you first have to find out what your T1, T2, and T3 is so that you can find a general term. Remember, we used to write it like this. So that you can formulate this and formulate this one. Sn is equal to n. Do you understand? So you have to get enough
Yes, ma'am.
information for you to be able to substitute either in this one or this one. So now with this, my T1 is equal to, remember I said we start at the bottom, where
Yes,
n
ma'am.
is equal to 4. So my T1 is where I substitute my 4. So I'm going to say T2 multiplied by 4 minus 4, which is equal to 8. No, sorry, which is equal to 4. Are you with me?
Yes, ma'am.
And then my T2, I'm going to say 2 multiplied by, now it's going to be a 5, because remember, we're just carrying on.
Yes, ma'am.
Minus 4 is going to give me,
6
and then T3 is going to be 2 multiplied by what?
by 6.
By 6 minus 4, which is going to give me an 8.
8.
Right?
Yes, ma'am.
So now I know what my sequence is. So my sequence basically looks like this. It says 4, 6, and 8. And I can see that it's an arithmetic sequence because I have a common difference of 2, right?
Yes, ma'am.
So I already know that my D is equal to 2 and my A is equal to 4.
4.
Right? So now what this tells me is that my sequence ends at 70, where my N is equal to 70. Are you still with me?
Yes, ma'am.
So what I'm going to do now, please hold on, is calculate what my N is when Tn is equal to 70. So I'm going to say 70. Sorry, let me just change this color. 70 is equal to, so I'm here by Tn is equal to A plus N minus 1D. I'm trying to work out what my N is, right?
Yes, ma'am.
So I'm going to say 70 is equal to my A, which I said is 4, plus my N minus 1, which I'm trying to work out at my D, which is 2. And then I'm just going to solve for N here, like I've been doing. No, wait, before you carry on, Lizzie, are you still with me?
Yes, ma'am.
Yes, before you carry on, I made a mistake, no? So we're not going to do this. Ignore that part. So remember I told you that my 70 up there is my last term, right?
Yes,
So if
ma'am.
my N, my last term, which is N, is equal to 70, then it means that we have, sorry, I just want to figure out something. Then it means that we have 70 minus 4 plus 1 terms in this sequence. Because remember that we didn't start our N here wasn't 1. If we started our N with 1, then I was just going to put my 70 as is, as it being my last term. But because we started at N is equal to 4, then I have to compensate for the 3 that we skip. I'm not sure if I'm making sense, because if here, do you see with this T1 where I'm pointing?
Yes, ma'am.
If this 4 was 1, then I was going to leave my 70 as is. But because my 4, this number here is a 4, I have to compensate for the numbers I skipped. So what did I skip? I skipped 1, 2, and 3. Right?
Yes, ma'am.
And that's why here at my 70th term, I know that is not my 70th term, but it's only my 67th term, because I have to minus the 3 that I skipped here in the beginning.
Yes, ma'am.
So I know it's a bit confusing, but just remember that because my N here at the bottom, my starting point was not at 1, but at 4, my end point has to compensate for those 3 I skipped.
So whenever our N is not 1, this is what we do.
Yes, I always have to make sure that I minus what I missed here. So if this was a 10, for instance, if my N was equal to 10, then I was going to minus the 9 I skipped from the 70.
Okay.
To get my last term. Do you understand?
Okay, ma'am. Yes.
So now this 67 is my last term. Are you with me?
Yes, ma'am.
So I know, because remember I said that whenever you see this sigma sign, we are looking for the sum. We are looking for this, the Sn, right?
Yes, ma'am.
So now I can say that Sn is equal to my n, which is 67 over 2, and then I just substitute the 2a, my a, which is 4, plus my n minus 1, which is going to be 67, minus 1 multiplied by my d, which is 2. I know it's a bit confusing, but it's there. Do you see it?
Yes, ma'am.
Yes. So just remember that you don't just take your 70 as is for it being your last term if your n at the bottom is not equal to 1.
Okay.
Yes. So what's your Sn? What's this answer here?
4,690.
4,690. Perfect. Okay, cool. Hopefully the second one will make more sense. What does it say? It says, what is the value of m for which? Okay, cool. So it says, what is the value of m? So my end point, if k is equal to 1, and then it says 5 multiplied by 3, k minus 1 is equal to 65, right? So this 65 is my Sn. Do you see that?
Yes, ma'am.
That's my sum. So what am I basically looking for? I'm looking for my last term.
Okay.
Which is my m. Do you see it? So
Yes, ma'am.
now I'm going to use my arithmetic, my geometric sequence, right? Which said that Sn is equal to a to the power of r n minus 1 over r minus 1. Do you remember this?
Yes.
So now
Ma'am, how
substitute my
did you
Yes.
how did you come to realize that you are using that formula?
I came to realize that we're using this formula because this last part here, whenever you see this, do you see this 5 and 3k to the power of k minus 1? Whenever
Yes,
you
ma'am.
see this k minus 1 as an exponent, that's when you know that it's a geometric sequence. So whenever you see this
Okay.
k minus 1 being an exponent, automatically you know that it's a geometric yes. So that's how you can tell.
Okay.
Yes. So are you with me?
Yes, ma'am.
Okay, great. So now after you substitute your 65, you go in. Okay, before we get here, let's figure out our terms first. So let's clear this and figure out what our terms are first. So now our T1 is equal to 5 multiplied by 3 to the power of, that's when you substitute your k. Your k is 1 minus 1, which is 0, right? So my T1 is going to be 1 multiplied by 5, which is a 5. And then my T2, I do the exact same thing. So I'm going to have a 2 minus 1, which then gives me 3 multiplied by 1 is 15. And then my T3 is equal to 5 multiplied by 3, 3 minus 1. That's a 2, that's a 9, that's 45. Right? And now you
Yes,
can
ma'am.
see what you are asking. Remember, you asked me, how do I know which equation you use? Now you can see it clearly, because when you say 15 over 5, it gives me a 3. And this is
3.
my R, remember. And I said that if
Yes.
my R is more than 1, then which equation do I use? That first one we did,
The
remember?
first one.
Yes.
ma'am.
So that's how you see it. So now I take it back to my Sn is equal to A Rn minus 1 over R minus 1, right? So now in this case, we are looking for my M. They used M instead of N. Do you see that?
Yes, ma'am.
So I'm going to say Rm here. So now my Sn is 65. I'm just going to carry on here, which is equal to my A. What's my A going to be?
5.
5, open bracket. My R is
Is 3.
3 to the power of M. That's what I'm looking for. Minus my 1 over 3 minus 1, right?
Yes, ma'am.
Then I say 3 minus 1 is 2, and I'm going to say 65 multiplied by 2. This is going to give me 130 is equal to 5, 3 to the power of M minus 1. And I divide by 5 and get 26 is equal to 3 to the power of M minus 1, which is then going to be 27 is equal to 3M. And what to the power of 27? No, what to the power of 3, sorry, gives me 27?
Is 3.
Yes. So what's my M?
Is 3.
My M is equal to 3. So I know it's a bit confusing, but I hope you are starting to understand it a bit.
Yes, ma'am.
Okay, cool stuff. Okay, I'm going to skip question 3 and just explain this last piece to you quickly. So whenever we're dealing with geometric sequence series, right?
Yes,
The
ma'am.
geometric series, it can either diverge or converge. Have you heard those two words?
Yeah, I think I
When
have.
Yes. So when it's a divergent series, it just carries on. So if I have a 2 plus 3 plus 4 plus 5 to infinity, do you agree with me if I tell you that the answer here is always going to increase and it's always going to be positive
Yes.
because it's increasing, right?
Yes, ma'am.
But the minute I have something that decreases or let me see, I want to get an example for you. Yes, the minute I have something like this, like 1 plus a half plus 1 over 4 plus 1 over 8, right? And I say calculate what your R value is. Your first R is going to be a half divided by 1, right? Which is equal to a half.
Yeah.
Right? And the
Yes,
rule
ma'am.
says that if my R is between -1 and 1. So if my R is less than 1, but more than -1, then I have a convergent series. Are you with me? So we're going to
Yes,
do
ma'am.
examples to explain this, but just keep this in mind, that if my R is between -1 and 1, then I have a convergence series. But if I only have positive numbers that are carrying on and getting bigger, then it's a divergent series.
Okay.
Okay, cool. Okay, let's just do these 3 questions quickly. So it says, so calculate s to infinity if my sum, I have a sigma notation here and I have infinity on top, starts at p is equal to 1 and it's 8. No, sorry. It's 4, 8, 1 minus p, right? So first I start by writing out my terms. So
My
what's
terms.
T1 going to be?
It's 8.
1 minus 1, right?
Yes, ma'am.
Which is equal to 8, yes. And my T2?
Is 2.
My T2 is going to be?
2. I know. It's 32.
Sorry, wait, I wrote that wrong. Oh. It's supposed to be 1 minus 2. So what's my
2.
T2 going to be?
It's going to be 2.
Yes. And my T3? Sorry, I know you're tired. We're
It's-
almost done.
And it's T3 is 1/2.
1/2. Perfect. Right? And now I can calculate what my R is. So R is equal to T2 over T1, which is going to give me
It's 4.
no, sorry, I wrote that wrong.
It's 2/8.
Yes, which is equal to
1/4.
1/4. So do you agree with me that my R is between -1 and 1?
Yeah.
Do you see it?
Yes, ma'am.
So that means that this is a convergent series, right?
Mm.
Yes. So now I forgot to give you this formula, but please write it down. That S to infinity is equal to
Yes.
A over 1 minus R.
Mm.
Do you have it?
Yes, ma'am.
So now all I have to do is substitute. I know what my A is. What's my A going to be?
It's 8.
Over 1 minus, and what's my R?
1/4.
1/4. So what's my S to infinity?
It's 32/3.
Yes, perfect. So just remember that whenever you see the sigma notation, get your terms first, then you can calculate after that. Does it make sense?
Yes, ma'am.
So always start by getting your term 1, term 2, term 3, then you can start calculating the rest. Okay, let's do number 2 quickly. So number 2 says, given the series 3 multiplied by 2x minus 3, 2 plus 3, yeah, given this series, you see it? And it says, for which values of x will the series converge? Now, what did I say about series converging?
Series that converge, they are between -1 and 1, and they are the series that they, what did they do again?
Yeah, that's fine. You just need to know
They
this.
don't increase like the main series. Yeah.
Yes. But as long as you know this, this is the most important one. You need to know
Yes.
this, right? So now if you have a question like this, if they say for which values of X will the series converge? First thing you need to work out is what's my R, right?
Yes, ma'am.
So what they gave me here, they gave me T1 is equal to 3, open bracket 2x minus 3, 2, right? And then
Yes,
T2
ma'am.
is equal to 3, 2x minus 3. And they have a 3. And then T3 is equal to 3, 2x minus 3. And then they have a 4. You see that?
Yes, ma'am.
So now I told you that R is equal to T2 over T1. So my T2 is this whole thing, which is 3, 2x minus 3 multiplied by 3 over my T1, which is 3, open bracket 2x minus 3, close bracket 2, right?
Yes, ma'am.
Do you see it?
Yes.
So do you agree with me if I say, sorry, please just hold on. I want to see if I can. No, you know what? I didn't copy this correctly. These 2's, this 2 and this 3 and this 4 are supposed to be exponents.
Okay, ma'am.
So it's supposed to look like this. Sorry about that. So it's supposed to be this to the power of 2 to the power of 3 to the power of 4. Do you see it?
Yes, ma'am.
So this is supposed to be there to the power of 3, that to the power of 2. So do you agree with me that this 3 is going to cancel with the 3?
Yes.
So what am I going to have left?
2x minus 3 cubed divided by 2x minus 3 squared.
And once I simplify those two?
After
Because
expanding there.
you don't have to expand them. Can you see that inside the bracket, we have the exact same thing?
They're the same. Yes, ma'am.
Yes. So it's the same as me having x to the power of 5 over x to the power of 2. What's my answer going to be? If I
3.
simplify that, it's x to the power of 3, right?
Yes.
So here, I'm just going to have a 2x minus 3 left. Because these two are
Yes,
going to
ma'am.
cancel, and then I'm going to be left with 1 here on top. Make
Yes,
sense? Okay,
yes.
cool. Okay. So now that I know what my R is, I take this R and I substitute it into this equation that you gave me. Then negative 1 is less than 2x minus 3, which is less than 1. And then I just solve for x. Do you see it?
Yes, ma'am.
So I first start by writing my terms out, and then I figure out what my R is. And then once I have my R, I take that and I put it into this equation that you gave me, that my R has to be between negative 1 and 1.
Yes,
When I'm
ma'am.
dealing with a converging series. So whenever they ask me, what are the values of x for which this will be convergent, then I know that I have to take my R and put it between negative 1 and 1 and then just solve for x. So how do you think I'm going to solve for x here? Where am I going to start?
You're going to equate, you're going to say 2. Okay, that's what I'm thinking. I'm not even sure. 2x
Okay.
is equal to 2x is equal to positive 3. Is it
Wait.
not going to be 2x minus 3
Remember
is
when we
equal to 0?
solve, but wait, remember when we solve inequalities, right? We start
Yes,
by removing this 3 first. So I'm going to have my 2x, I'm going to leave it in the middle, and I still have my greater or less than signs. And then I take my negative 3 to my left. So it's going to be a positive 3. Are you with me?
Yes, ma'am.
When I take this side. Do you see it? So
Yes,
what's
ma'am.
negative 1 plus 3?
It's positive 2.
Positive 2. And then I take the same 3 and I bring it to my right-hand side. So what's positive 3 plus 1?
It's 4.
It's 4. And then what am I left to do? I get rid of my 2, this one. So I'm going to say x, and I put my greater and less than signs. And then what happens when I divide 2 by 2?
It's 1.
I get a 1. And then on the right-hand side,
You get 2.
I get 2. So this is going to be my final answer. Do you see it? So don't forget that when you're dealing with inequalities, I'm trying to get rid of everything until I'm left with just an x. But whatever I do on my left-hand side, I have to do on my right-hand side as well.
Yes, ma'am.
So did you see it?
Yes, ma'am.
Yeah, so please practice this a lot because they do love these questions about converging series.
Okay.
So just remember, you write your terms and then you get your R and then you put your R between your negative 1 and your 1. And then you just solve for x.
Okay, ma'am.
Okay. Okay, now please do this last one for me. Let me just check if I copied it correctly. Yes, I did. Please do this last one for me. So it's the same. Yes, number 3. Number 3, we're going to do it the same way we did, which one was it? Number 2 here. Remember this number 2?
Okay.
Yes,
ma'am.
that's how we're going to do number 3. This one, please do it for me and then you let me know when you're done.
Okay, ma'am.
Are you coping, Lizzie?
Yes, ma'am.
Oh, okay. You let me know when you're done.
Yes. So. I found my M as 5.
Perfect. That's really good. M is equal to 5. Okay, so let's do it together quickly. So
Yes, ma'am.
you started at T1, T2, and
Yes.
T3, right? So what was your
Yes,
T1?
ma'am. It's 3.
Your T1 is 3, so you substitute 3, 2, 1 minus 1 is equal to 3, right?
Yes, ma'am.
And then you have your 3, 2, okay, which is 2 minus 1. This was 6.
6.
And then you have your 3, 2, 3 minus 1, which is, and this is 12.
Yes, ma'am.
Okay, perfect. And then you figured out your R to be,
2.
which is 6 over 3, which is 2. And then you substituted into which equation?
The first one on the geometric sequence.
Yes, your first one, because your 2 is more than 1, right? So you're going to say
Yes, ma'am.
A, minus 1 over R minus 1. So your A value is?
It's 3.
Yes. Your R is 2, M minus 1 over 2 minus 1. And your SM, they gave it to us as 93.
Yes, ma'am.
And then you just solved your M to be 5. That is amazing.
Yes.
Well done.
Thank you.
Yes, so we are basically done for the day. Thank you so
Okay,
much
ma'am.
for joining and for participating. I really hope it helped a lot.
Yes, ma'am. Thank you.
No, you're welcome. And I think Surprise wanted to talk to you quickly before you leave.
Yeah. Thanks, my Bonnie, for the handover. Lizzie, could you
Okay.
please send your details on the chat so I can just take down your details and we'll contact you. Are you able to do that?
Yes, ma'am. Let me